Good day. In this video, I'll be tackling the geometry from last year's exam. So the grade 12 geometry from last year's exam. And I'll basically be going through the questions. I'll be looking at circle geometry particularly. And we start with question 9. Question 9 is a proof. And they basically want you to prove this theorem. So when you walk into an exam, it's always better to study each and every proof so that if it does get asked, you memorize the steps and you'd rather focus on understanding the proof as opposed to memorizing it. So that's the proof of the angle at the center is 2 times the angle at the circumference. Or conversely, or in reverse, the angle at the circumference is 2 times the angle at the is double the angle at the center. So that relationship of 2x and x. So that's a proof. It's not too bad. Then we get to our first question. So whenever you see a question, it's always better to make your own changes before you even look at the question. So I won't look at the question, so I'll just hide them for now. And then I'll say in the diagram, O is the center. So we have a center, and we have a diameter, and we also have a tangent to the circle at F. So we can circle all of our keywords. So we have diameter, that's a keyword. We also have a center, that's also a keyword. And then we also have the word tangent. And then we're given the fact that the angle P is 32. Let me just get my calculator. The angle P is 32. So that means we have enough information. So since that's the center, these are all going to be radii. So OP, OL, and OS are all equal. Therefore, OLP is an isosceles triangle. An isosceles triangle always has the base angles are always equal in an isosceles triangle. So that's an important fact that a lot of learners forget across all grades, and it does impact how they answer their geometry questions. So angles opposite equal sides, or conversely, sides opposite equal angles, those are important. And then over here, we have, so we'll say 180 minus 32 minus 32. We'll get 116 over here. That's because of sum of angles of a triangle. Then we have a straight line or supplementary angles over here. We say 180 minus 116. And then we have a 64. So we have 64. So now we are done with triangle OLP, and we can move on to the other triangle OMF. We see here we have a tangent and a radius. So tangent and a radius always give us a 90. So that's 64. Then in triangle OMF, we have 64 plus 90 plus angle M gives us 180. So we can say 180 minus 64 minus 90. And then we have a 26 degrees. So we've actually solved all of the questions here, all of the angles here, and we're using the fact that we have the tan chord theorem. This is the tangent perpendicular to the radius. The tan chord does not appear here, only these two theorems appear. And the isosceles triangle appears because we have a radius. A radius will form equal angles. So now they want we'll just scroll up. The size of O2 and M. So right here, they want O2 and they also are looking for M. So we've already found those two angles. So the shortest route or the shortest definition would be to use, you can use exterior angles for a triangle. So that's an older theorem. So you can use exterior angles of a triangle. So you can say 64 is the exterior angle. It'll equal the sum of the two interior angles. So it's very useful rather, to remember all of your old geometry. Things like parallel lines, perpendicular lines, and something else for triangle, because those all come back in grade 12. So that's the exterior angles of a triangle theorem. And then you could say 64 will be O2 because it's 32 plus 32. And you'll say L is 32, angles opposite equal radii. OL and OP are both radii in this case. So that would be how you'd answer that. You'd first say OP equals OL radii. L is 32. Angles opposite equal radii. O2 is 64. Or O2 is 32 plus 32. Exterior angles of triangle OLP. Then you get 64. For the M, you'll say F is 90. That's because the tangent is perpendicular to a radius. So tangent perpendicular to the radius. And then you can use the sum of angles of a triangle to look at triangle OMF. Once we add all of those, we get 180. And then you can say M plus 64 plus 90 equals 180. Sum of angles of a triangle. Then you can say that that's going to be 26. So all of the angles for triangle, those sum up to 180. That's important. Then once you extend it, you get an exterior angle. So that angle actually becomes the sum, becomes y plus c. You can see here, becomes the sum of the exterior two angles. Of course, if you're not looking at the x as it relates to 180, you could say, but that's 180 minus x. That's true because we're working with variables here. If I had real numbers, then it would definitely satisfy. And we have 32 and 116. It does satisfy. So don't let variables confuse you or intimidate you. They're just there to test your algebra in some cases. 116, those are equal. Then we have two 32s, and these are the two opposite angles. So opposite angles, and they are exterior angles of a triangle. This is a very old theorem, so it's not really new theorems that I'm using. The only new theorem I used here is this one, and the fact that we have radii. So we have this radii isosceles triangle occurring. You have a center O, then you have two equal lines. So that's this question for O2 and M. So please take your time to analyze the question before you even answer the questions, and make sure that your reasons are written out properly. Thank you very much.